In this lesson, we're going to talk about transforming a linear function through several different ways. And in case you're wondering what transforming a linear function means, it basically means that we are going to take a line and move it to a new location. And there are 6 different ways that we can do this. It is through translation, both horizontally and vertically. There's also a stretch, vertical stretch, and a vertical compression. They're essentially the same, but we'll cover what the differences are. So we'll count that as one category. And then there's a horizontal compression and stretch, which are grouped together as well. And we'll go over the slight differences between the two. So even though I have 6 categories listed, horizontal translation, vertical translation, and then the rest of these 4, it's really essentially 4 different categories. So horizontal translation, vertical translation, so that's 2, and then the next 2, vertical stretch and compression, I would count as a 3rd category, and then horizontal compression and stretch as the 4th category. Okay, so let's go ahead and dive in to each one of the 4. For this first function, we have the equation f of x is equal to x plus 1. This line has a y-intercept of 1, which is right here, and a slope of 1. Rise 1 from the y-intercept and then run to the right. So the slope is rise over run, or 1 divided by 1, which is equal to 1. Okay, I went ahead and labeled the tick marks so that it's easier to read. And now we have another function in blue, and it is essentially the same as the function in green, f of x, but shifted down 1, 2, 3, 4. Okay, so that went down minus 4. And let's go ahead and label that. Okay, there it is. And so our new function, we're going to call g of x, is now equal to, and we're going to write the same thing as the function in green, f of x. So we're going to call this x plus 1. Okay, but we're going to add the shift going down, which we will call vertical translation of negative 4 to the equation, and so it will look like that. And this is called a vertical translation of negative 4. Okay, so as you can see, we had the function f of x in green of this line, and it basically shifted down 4 places. The line is parallel to f of x, which is the line in green. It just shifted down by 4 places. Okay, so that's a vertical translation. So let's go ahead and take a look at what the next one looks like. Now, before we move on to the other translation, let me go ahead and give you the formula for a vertical translation. That is, f of x is equal to mx plus b plus, I'm going to call this k for the translation. Okay? And there we have it, vertical translation formula. Now, here we have a function in green, and we're going to call this f of x is equal to, and the slope is 2, with a y-intercept of 2. Okay? So So y-intercept here is 2, and we have a slope of 2 because if we rise 2 and we run over 1, that's 2 over 1, which gives us a slope of 2. Now if we have the following line, you'd see that there is actually a horizontal translation of 2 to the right, or a plus 2. So let me go ahead and draw that in. Okay, so it's a plus 2 because it's a shift to the right of 2 places. Now, I'm going to go ahead and give you the formula for horizontal translation, and that is horizontal translation and that formula is f of x is equal to the slope times x minus k plus b. Okay, so if we were to write the equation of this blue function, or this blue line, we would take this formula and enter all of the information from the green line, or the green function, f of x, and put in the slope and the y-intercept, and the only thing we would add new would be our k, which would be a positive 2. Okay, so let's go ahead and write that in. Our new function would be g of x equal to 2 times x minus, I'm going to put a space there for now, plus 2. Okay, so you see that my slope from f of x is brought down to g of x. My y-intercept from f of x is brought down to g of x. Now, I left this blank because I just wanted to take a second to explain that we're going to put the value of k in this spot. In this case, it's a positive 2. And so we would write positive 2 right here. If the horizontal translation moved to the left, we would have a negative translation. And so that negative number would go in here. And so you would have a minus negative, whatever that translation is, which then would become x plus the number of movements to the left. Another way to look at it is if the translation is to the right, meaning it's a positive translation, then the symbol in here would be a negative. On the other hand, if the translation was to the left, meaning a negative translation, then there would be a plus sign inside here. So the signs would be the opposite of the actual movement. So a plus translation will give you a negative sign, a negative movement will give you a positive sign. Okay, moving on to the next one. So let's say we have the following function, and this equation is f of x is equal to x plus 1. If we have a vertical stretch, then the equation for a vertical stretch would look as follows. Vertical stretch, f of x is equal to, and here's our k, times mx plus b. So if we have the following graph, the blue line would have the following equation. And so we're going to go ahead and type in all of the same information as the green line, or the green function. Let me rename this as g of x. So we're going to have x plus 1, okay? The difference here is we now have a k of 2 because the slope of the new line is 1, 2 over 1. So it has a slope of 2, and so the vertical stretch here is of 2. If you were to multiply this out, you'd see that g of x is actually 2x plus 2, right? We're distributing a 2, and we see that the plus 2 would tell us that the y-intercept is at 2 with a slope of 2, which is 1, 2 over 1. So rise over run gives us a slope of 2. So we have a vertical stretch of f of x is equal to k times mx plus b when k is greater than 1. So when k is greater than 1, we have a vertical stretch. Now, let's take a look when k is not greater than 1. So here we have the function f of x is equal to 2x plus 2. And now let's say we have the following line. And the equation of this line is g of x. And we're going to copy this whole thing. Copy the same equation as f of x. Okay, except now our k value is 1/2. When this happens, we have what's called a vertical compression. And the equation for this is the same as the vertical stretch. F of x is equal to k times the quantity mx plus b, where the absolute value of k is greater than or equal to 0, but less than or equal to 1. So what this means is if k is greater than 0 and less than or equal to 1, so let's say 0.2 or 0.4 or 1/2 or 3/4, then we would have a vertical compression. Likewise, if k were negative 0.2 or negative 0.4 or negative 1/2 or negative 3/4 as an example, then we would also have a vertical compression. Okay, one slight adjustment is it should not be equal to, it should just be the less than and also for this should also be just less than, okay? So k cannot be equal to 0 or 1. That would not be a vertical compression. So it would have to be between 0 and 1 for the absolute value of k. Okay, let's move on to the next transformation. Okay, so this following line has the equation f of x is equal to x plus 1. We now have another line colored in blue, and this function has a transformation of the following. We'll call this g of x is equal to, this will be the k would be 2, and the rest of the equation would be x. Oops, wrong color. No, that's correct. X plus 1. And what we have here is called a horizontal compression. And a horizontal compression has the following equation. F of x is equal to k times mx plus b. And just to clarify, this is when or where k is greater than 1. So in this case, for this function, g of x, we say that there's a horizontal compression of 2. Okay, and then for the last transformation, it'll be similar to this one, and it'll look like this. So the function of this line is f of x is equal to 2x plus 2. And then the next transformation will look as follows. And we will call this g of x is equal to, and I'm going to just copy the same thing, except we will now have a different transformation of 1/2 for the k value, and this comes from the following equation, which is a horizontal stretch. So horizontal stretch has the following equation. F of x is equal to k times the mx plus b, except this time it's where k, the absolute value k, is greater than 0 and less than 1. So what this means is if k is anywhere between 0 and 1, let's say 1/4 or 1/2, then this would be considered a horizontal stretch. Okay? Similarly, if k were -1/2 or -1/4, it would also be a horizontal stretch because we would take the absolute value of that k, and that would satisfy this condition of being between 0 and 1. Okay, so I just covered all 6 transformations. There's a lot involved here. I would highly recommend that you listen to the recording one more time to really understand and capture anything that you may have missed the first time around. Thank you.